In this video, I'll evaluate the fluid, thermal, and structural performance of a butterfly valve and control mechanism using AIM 17.0. Using AIM's integrated geometry modeling, I can quickly create the piping and valve assembly and extract the fluid volume. Using AIM's robust automatic meshing, I can rapidly generate a mesh for the fluid and solid regions of the model. Next, I'll review the fluid setup. There's a high pressure, high temperature inlet, a low pressure, low temperature inlet, an outlet, and a convection boundary condition on the outside surfaces. Shown here are the fluid results, which show the velocity magnitude of the hot gas and how it flows through the butterfly valve. The temperature contours show the thermal gradients in the piping and valve assembly based on the mixing of the hot and cold gas flows. Next, I'll review the structural setup. The piping system includes 3 structural supports. And physics coupling interfaces map fluid forces and solid temperatures to the structural model. The piping assembly is connected through automatically detected bonded contact. In the control mechanism is connected using both structural joints and frictional contact. Next, I'll review the structural results. The displacement magnitude shows the valve deformation based on the hot gas flow. Shown here are the equivalent stress results in the T section based on the fluid forces and solid temperatures applied from the fluid solution. Next, I'll define a parametric study to evaluate the outlet temperature and thermal stress as a function of the inlet temperature. The results of the design point study allow the rapid evaluation of the mixing efficiency of the butterfly valve assembly. Thank you for watching this demonstration of ANSYS AIM.